Am I audible, sir?
Yes, very much.
Thank you so much, sir. Thank you so much. So, with your permission, sir, may I start the session, sir?
Yes, please. Go ahead.
Okay. Thank you so much, sir. Thank you so much. A warm welcome and very good evening to all dear participants. The resource person of today's session, our respected Dr. Anil C. Mathew, sir, and chairperson of today's session, respected Dr. Padam Singh, sir. Today, we are having our session on basic concepts of regression. Now, I would like to introduce today's resource person of the session, Dr. Anil C. Mathew, sir. Dr. Anil C. Mathew, sir, obtained his MSc degree in Biostatics from Christian Medical College, Vellore, University of Madras, under the guidance of Professor P.S.S. Sundar Rao, and PhD in Biostatics from Bharatiya University, Coimbatore, under the guidance of Professor S. Krishnamurthy. He started his career as assistant statistician in the rheumatic heart disease control project of the Indian Council of Medical Research at All India Heart Foundation, New Delhi in 1988, and afterwards joined in PhD Institute of Medical Sciences and Research, Coimbatore, as assistant professor in 1989, as associate professor in 2003, and as professor in 2008. He has been actively engaged in teaching and research in applied biostatics for 3 decades and a reviewer member of editorial committee of various national international journals, include Indian Journal of Medical Research, American Journal of Epidemiology, and the BMJ Online. He was an invited participant in the Indo-US workshop series on clinical research organized by US Embassy New Delhi and during 2007 to 2009, and the statistical expert for preparing the course material of the Applied Biostatics course of Indira Gandhi National Open University in 2011, a statistical expert of the Task Force Committee on Geriatric Research, Indian Council of Medical Research in 2011, member of the Expert Award Committee of International Biometric Society, International Biometric Society, Indian regional correspondent during 2015 to 16, and visiting professor biostatics and epidemiology at Sultan Qaboos University, Sultanate of Oman in 2015. Member of the Executive Council and Award Committee, ISMS 2017 to 19, and member of Executive Council, International Biometric Society, Indian region during 2017 to 18. In recognition of the eminence achieved by way of his outstanding contribution leading to the promotion of statics in medicine, Dr. Anil C. Mathew has been conferred on fellowship in medical statics of the Indian Society for Medical Statics for the year 2017. Sir visited several countries including Bangladesh, Malaysia, Sri Lanka, Kuwait, Nepal, Oman, Indonesia, and UAE for chairing scientific sessions and organizing short courses. Now, I would like to invite sir to kindly lead to this session. Please, sir. Welcome, sir.
Yes, Dr. Mathew, please start your session. Welcome from my side.
We have PPTs. If there is any issue, sir, let me know. I will share from our side.
Amit, is it audible, Amit?
Yes, audible, sir. Audible, sir.
Thank you, Dr. Amit Kumar, and also thank you, Dr. Shubham Pandey and Dr. Padam Singh for inviting me for this program. And my special thanks to the organizers of the Institute of Applied Statistics and National Institute of Ayurveda on this program of certificate program on the research methodology and biostatistics. I think it's a good initiative in the national level. And thank you once again for inviting me. And my talk today is on correlation and regression. Is it audible?
Yes, sir. Yes, sir. Visible and audible, sir.
Is it possible to view this chat box now?
Yes, yes.
Okay, good.
Okay. Yeah, the topic today is correlation and regression. Let us have a discussion on this particular topic. Do you believe that whether there is a relation between the number of churidars, or for the gents it is the number of t-shirts, and your examination mark? I like to give the response in the chat box. That means the question for you is, if you have more churidar, is there a chance of getting you more marks in the examination? Or if a number of jeans is more in your shelf, the chance of getting more marks, is there any relationship? That's the question number one. Let us see the response from the chat box. Yeah, you can send your response in the chat box. No. Okay. Yeah, most of you are responding that there is no relationship between the number of churidars and the examination score. But when I discuss this particular topic among the UG students, I have get lot of different responses. Somebody saying that absolutely there is no relationship between number of churidars and the examination. There's some response they are telling. Other students, what they told is that if you have more number of churidars, you don't have to spend more time for washing your clothes. That much of time you can use for your study purpose. So chance of getting more marks in the examination is very high if you have more churidars. That is another response which I got from the students. Another response which I got from the students is, yes, there is a positive relation between the number of churidars and the examination. So because those who are having more churidars are likely to come from rich families, so they may have provided more tuitions and more education attention from parents side. They will get it. So eventually the examination score are likely to be very higher. But there are other responses also I got from the students. Like some students, they are responding that if you have more churidars, they have to spend more time for shopping in the mall and other things. So they are wasting their time from the study, and accordingly, the chance of getting less mark is more than more marks. That's another response which I got from the students. So there are different types of responses which we are getting this type of a scenario. Another example which we just thought of sharing with you is the distance from the college and the examination score. Even for this also, when I discuss in the UG student, I am getting different responses. Some says that when the distance increases, the chance of getting more marks is very less, because if lot of time they have to travel here and there, if those who are in the hostelates, they can even spend time in the library. So when the distance increases, the chance of getting more marks is very less. That's some response which I'm getting. But the other responses which they are telling is, yes, those who are hostelites, they may not get that much of comfortable food, comfortable attention from the parents. Other people are usually come from the home. The parents may take them for better tuition, better food, so many other things they may get. So chance of getting more marks are there. So they are saying that the more distance, the chance of getting more marks are there. Some people are saying that when the distance is very far, more far, it is a negative correlation. So responses are different. Some people say that it's a positive correlation, and some people say that it is a negative correlation. Another example which I just thought of sharing is parents' education and the examination score. The more parents are educated, the chance of the student to get more marks. How is the correlation? Here also there are different responses are there. As such, it is parents' education doesn't have any role with the examination score. It is how the child study is more important. There are so many parents which are very educated, but the children, they find it difficult in passing the anatomy examination itself is there. So absolutely there is no relation that some people are saying. Other people are saying it is not like that way. The parents are more educated, the chance of scoring their children's mark is also very high. So everywhere we are having different responses are there. So this is a very important example which I just like to discuss with you. When in the reality, when you collect the data also, sometimes we may think that's a positive correlation. Sometimes we may think that is a negative correlation. But what exactly uh, what the data tells is the most important thing. And the last example which I just thought of sharing with you is age of the car and the selling price. Of course, there's not much of debates are not there. It's a negative correlation. Age of the car increases, the selling price likely to decrease. Is it audible or not? Okay. So here is one data between the distance and the number of visits. Real life situation. This is one example which I tell you. Many times students consider statistics as part of mathematics, but it is not exactly the same thing. In mathematics, it is only cocksure things only. 2 into 3 is equal to 6. Whoever multiplies 2 with 3, you will get only 6. But in statistics, it is not like that way. Here is an example between the distance from the health center and the number of visits. For example, most of the Ayurvedic students, the far away those who are staying, the chance of visiting your Ayurveda clinic, how is the correlation? Here, example of we have collected some data. The first two people, they are staying 2 kilometers away from the center, and the number of visits are 6. Third person is also staying 2 kilometers away from the center, but she made only 5 visits. The fourth and fifth person, they have different distance. Fourth is 4 kilometers and fifth person is 5 kilometers, but they made 5 visits. It is not like exactly like mathematically how it is happening. But the next two patients 6 kilometers away from the center, they made 4 visits. And next person is also stayed 8 kilometers, but she also made 4 kilometers. Next patient stayed 9 kilometers from the center, but she made 3 kilometers. And the last patient stayed 10 kilometers from the center, and she made only 1 kilometer. But the question here it is, what is the relationship? When the distance increases, what will happen to the number of visits? So it is not exactly like a mathematical way, but overall, when you plot this data, when the distance increases and the number of visits, distance in the x-axis and the number of visits in the y-axis, what you can see is there's a decreasing trend which we can see. So this is actually what we call it as statistics. When distance increases, the number of visits are likely to decrease. This is very clearly evident from this type of a diagram, which is actually what we call it as scatter diagram. So what is an example of a positive correlation? The more time you study, what will happen in your examination? Here is a scatter diagram indicating the relationship between the number of hours spent studying and your examination marks. You can see that when the more time when you study, the chances of getting more marks are very high. This is actually one example of what we call it as positive correlation. So the previous example which we told is an example of a negative correlation. When the distance increases, the number of visits are likely to decrease. But this particular example, the number of hours, the more time when you spend it, the chance of getting you more marks are very high. So this is an example of what we call it as positive correlation. And there are some of the relationships we may not have any relationship also. For example, the pulse rate and the weight. When you plot this in a diagram, we are not seeing any kind of relationship. So eventually we have only three types of relationships. One is called a positive correlation. Another is actually what we call it as negative correlation. The last is actually no correlation. So when you see this correlation analysis versus regression analysis, the correlation analysis measures the strength of the association involving two continuous variables. Here one requirement is there, the both of them should be continuous variables. The examples which we told is the distance and the number of visits. Distance is also in the continuous variable and the number of visits also in the continuous variable. And the second example which we told is the time spent for studying and the examination marks. Time spent for studying is also in continuous variable and the examination mark also in the continuous variable. So the correlation analysis measures the strength of the association involving two continuous variables. Whereas the regression analysis derives a prediction equation for estimating the value of one variable. Usually we call it as dependent variable with the value of another variable which is called the independent variable. In the first example which I told you, the distance and the number of visits. In correlation analysis, dependent variable or independent variable is immaterial. That's not much of our concern. Whereas in the regression analysis, we are more concerned about one is in the dependent variable, another is the independent variable. For example, in that study, the number of visits is the dependent variable. What we are testing through this data analysis is whether distance increases, the number of visits decreases or not. So this number of visits is the dependent variable and the distance is the independent variable. So basically what I am conveying is correlation analysis measures the strength of the association between two continuous variables. That's the first thing. And second thing is regression analysis derives a prediction equation for estimating the value of one variable. That variable is actually called a dependent variable, which is the value of another variable, which is called the independent variable. The second example, our primary concern is the marks of the student. It is not the time spent for studying. It is not the dependent variable. Our primary concern is the marks of the student. How the marks associated with the time spent during the study time. So that is called, one is dependent variable, another is called the independent variable. So the data representation in the correlation analysis and the regression analysis, the data used in the correlation or regression analysis pairs of measurements made on the same unit of observation. The pairs are denoted symbolically by xi, yi. The first example I told you, it is a pair actually. One pair, how much is the distance they are staying away from the center and how many visits they are making. Yi is representing the number of visits. They are representing the distance away from which they are staying. And the second example, xi represents the time, number of hours they are spending for study. And yi representing the marks which they are getting in the examination. But the data is always in the form of pairs. Conventionally, in regression analysis, y represents the dependent variable and x represents the independent variable. So at the end of this correlation analysis, what we are going to get is, we are getting a Pearson correlation coefficient. This Pearson correlation coefficient, remember please, when we compare this correlation analysis, both variables may be in two different units. The first example which when I mentioned is distance and the number of visits. Distance measuring is in kilometers and the number of visits which they are making as the frequent, how much time they are visiting. But at the end of this analysis, what we are getting is correlation analysis. This correlation coefficient, the Pearson correlation coefficient, it is a unitless measure that describes the strength of the linear relationship between the two variables. And the correlation coefficient, R value, ranges from -1 to +1. And the sign of the correlation, there are two things are most important in the correlation analysis. One is the sign of the value and the magnitude of the correlation. Sign, for example, sign you will get either positive or negative. When it is a positive, it indicates the one value is associated with the positively or correlating with the other value. When it is negative, it indicates one value increases, the other value decreases. So there are two things are there. First is called the sign of the correlation, and second is called the magnitude of the correlation. When R value, when it becomes -1, it indicates perfect negative correlation. When R value, when it is +1, it indicates perfect positive correlation. When R value it is 0, it indicates no linear relationship. So the sign of the correlation coefficient, the sign of R denotes the nature of the association, while the value of R denotes the strength of the association. For example, in the correlation analysis, the R value, when it is 0.9, it indicates the strength of association is very high. Whereas if the R value is 0.1, it indicates the strength of association is very, very poor. Similarly, the sign denotes the nature of the association. It can be R value can be either positive or R value can be negative. If R value is positive, it indicates a positive correlation between the two variables. When R value is negative, it indicates a negative correlation. The first example which I mentioned, the distance and the number of visits, the R value is likely to get a negative correlation. Whereas the second example, the examination marks and the number of hours they are studying, the R value is likely to get a positive value. These are some of the scatter plots of different correlation coefficients. The first is an example of -1 correlation. Second is an example of -0.6 correlation. Third is an example of correlation 0. Fourth is an example of correlation +1. And fifth is an example of correlation 0.3 plus 0.3. And the last is sixth is an example of correlation 0. Now, when we have a look on the magnitude or strength of the correlation, if R value is between 0 and 0.25, it indicates weak correlation. If R value is 0.25 to 0.75, it indicates intermediate correlation. If R value is between 0.75 to +1, it indicates strong correlation. If R value is 1, indicates perfect correlation. And if R value is 0, it indicates no linear association or correlation between the two variables. The examples are positive correlation. Example is diastolic blood pressure and age. When the diastolic pressure usually increases when age increases. The example of a negative correlation is when the distance increases, the number of visits to the health center decreases. How to do the correlation analysis? Here is the data between distance and the number of visits. When you run this program in the SPSS, this is the format which they are giving in the SPSS. The distance and the distance, the correlation is always 1 only. But the distance and the number of visits, the correlation, this is actually what we would like to say. In this example, it is -0.912. They are putting 2 stars. 2 stars indicate it is significant at 0.01 level. If it is only 1 star, it indicates significant at 0.05 level. And if there are 3 stars, it indicates significant at 0.001 level. And 2-tailed significance, only what we are looking for it. And this is the statistical significance, how you should look into the correlation table value. And usually it is n-2 degrees of freedom. When you do the correlation, if there are 5 pairs are there, and you have to calculate the correlation coefficient. And for 5 pairs, the degrees of freedom is 3 degrees of freedom. If the value is more than 0.878, it is significant at 0.05 level. If you have 7 pairs, if your correlation coefficient is more than, if it is 5 degrees of freedom, you have to look for it. If your correlation coefficient is more than 0.754, it is statistically significant. But numerically, how we should calculate it? There's a formula for calculating the correlation coefficient, which is called the sigma xy by n. minus x bar y bar divided by the standard deviation of x into standard deviation of y. And the standard deviation of x is sigma x square by n minus x bar square. I will make this concept very simple how to calculate. There are two variables are there. First is called x and second is called y. This is such they are the pair data. We have to create another three more columns. The first column is xy column, and second column is x square column, and the last column is called the y square column. So the pairs are x and y. In this example, distance and the number of visits. We have to make three extra columns: xy, x square, and y square. Then you have to make the sum of all these things. The sum of x, the sum of y, the sum of xy, the sum of x square, and the sum of y square. The sum of x divided by the number of observation, it is the mean of x. The sum of y divided by the number of observation, it is the mean of y. In this example, it is 54 by 10. 5.4 is the mean of x. And 43 divided by 10, 4.3 is the mean of y. And we also need to calculate the standard deviation. For that purpose, sigma x square by n. Sigma x square is 370. So 370 divided by 10 is equal to 37. So 37 minus x bar square, 5.4 the square. Then you take the square root of it. That is the standard deviation of x. Similarly, the standard deviation of y is equal to root of sigma y square by n minus y bar square. In this example, sigma y square is equal to 205 by 10, 20.5. So 20.5 minus 4.3 the whole square. Square root of it will be the standard deviation of y. And sigma xy by n will be 196 divided by 10. So substituting this formula, you will get the correlation coefficient of minus 0.91. So now we are looking for the linear regression analysis. The linear regression analysis predicts one value based on the other value. Here we are more concerned about how much visits they will make if a person stays from 3 kilometers away from the center or 4 kilometers away from the center. This is actually what we call it as simple linear regression. When a relationship between two variables exists, one can predict the value of one variable when the value of the other variable is known. Y is equal to alpha plus beta x. Here primary concern is what is the expected number of visits for a woman staying at 4 kilometers away from the center. There are two ways which the parameters can be estimated. One is called the least square method, other is called the maximum likelihood method. When you run the regression analysis in the SPSS, this is the way which we are getting the regression analysis. The first column is our primary concern. The regression coefficient for distance is minus 0.462 and the constant value is 6.793. So basically, the regression equation is minus 0.462 into distance plus 6.793. This is the regression equation. So the number of visits is equal to minus 0.462 into the distance plus 6.793. This is the regression analysis. For example, if a person is staying 4 kilometers away from the center, his expected number of visits, the regression equation is minus 0.46 into distance plus 6.7. So if a person is staying 4 kilometers away from the center, his expected number of visits is equal to minus 0.46 into 4 plus 6.79. He is likely to visit around 5 visits. That is a regression analysis interpretation. As I told you, the best fitting, there are many methods are there. In this regression analysis, we are using the least square regression method. What the least square regression will do is, the best fitting line is defined as one which the sum of square distance is minimized. Each points we take it, and which line will minimize the sum of squared distance is what we look in the least square analysis. So this is the way which we can draw the regression line. In SPSS, if you wanted to do this regression analysis, the commands are graph, legency dialog, scatter plot, then simple, define, OK, double click. Then they have option for the elements and fit a line to total. This is a command which we have used the SPSS to obtain the regression line. So basically what I'm conveying is correlation analysis is restricted to studies in which both the variables are random. Whereas regression analysis may be used in either the following. When both the variables are random, that's one option. Another is when one variable is fixed and the other variable is random. We have one more term which you should look into this study, which is called the coefficient of determination. The coefficient of determination, R-square value, measures the proportion of the variation that can be attributed to the variation in the second variable. So when you do an analysis of correlation coefficient of infant mortality and mother's literacy, when the correlation coefficient is 0.7, but we have one more indicator which is called the coefficient of determination, the R-square value, 0.7 into 0.7, which is called 0.49, that is 49%. What is the interpretation of this 49%? The 49% of the variation in infant mortality rate is explained by the mother's illiteracy. That means remaining 51% are due to the other variables of the infant. So 49% in that data explains are basically due to the mother's illiteracy. So the coefficient of determination measures the proportion of the variation that can be attributed to the variation in the second variable. So in this example, when R-square value is 49%, the 49% of the variation in infant mortality rate is explained by mother's illiteracy. And adapting to non-linear data, linear transformation of the data, you can use it, or non-linear regression analysis, which we can use it. The proper interpretation of the correlation coefficient. Remember, please, the correlation does not imply causality. The first example which we have discussed is the number of churidars and the examination score. There may be a positive correlation between the number of churidars and the examination marks. As we discussed, the more number of churidars are the students who are coming from more socioeconomic status. And those who are having the more socioeconomic status likely to give better attention to their children. Accordingly, they may be getting more marks compared to the other students. That is a positive correlation which we observed it. But at the same time, it doesn't imply causality. That means giving churidars in the hostel will not increase the marks of the students. The conveying message is the correlation does not imply causality. Another important thing is a statistically significant correlation does not imply that the association is clinically significant. This is a very difficult situation. Like sometimes what will happen is that you may be getting a correlation of 0.8 or 0.9, but it is not statistically significant. Many times the postgraduate students used to ask me this common doubt. In one place, they are getting correlation coefficient of 0.9, which is not statistically significant. Is it important? Another place, their correlation coefficient is only 0.2, but it is statistically significant, which is important. I will say both parts we should look into it. One is statistical significance, another thing is magnitude of the association. When the magnitude of the association is very low, even if it is statistically significant, it is not actually clinically not significant. So we may, on the other hand, if the value is very high and it is not statistically significant, it indicates observed association just due to the random chance only. So we have to look the statistical significance and the clinical significance for the proper interpretation of the study. So a clinically significant association does not imply that the association is statistically significant. As we all know, the size of the p-value does not specify the magnitude of the association. In the concluding sessions, the null hypothesis of the correlation coefficient is rho is equal to 0, and the null hypothesis of the regression analysis is beta is equal to 0. And the correlation measures a simple linear relation, and correlation does not imply causation. And correlation measures the degree of association. And p-value measures whether the association is due to random chance or not. And R-square measures the amount of variation explained by the independent variable. And thank you. Now this is the time for chat box. Time for discussion. You can give your questions in the chat box.
Yes, definitely, sir. Thank you so much, sir, for very amazing session. Now I would like to request all participants, then like if there is any query regarding today's session, then please write in either in the chat box or simply raise your hand so I can send you the unmute request. All participants are requested, then please write your query either in the chat box or simply raise your hand so I can send you the unmute request. Dr. Sonia Escale, I
Hello.
sent you the unmute request, please.
Sir, I would like to ask if, right, what you said in the last slide, if the values are statistically significant, it may not be necessarily clinically significant and corollary. So my question is, what is the purpose of such methods of analysis then if it is not going to get us or drive us towards the results expected or
No, what I have told is we need to look both the statistical significance and the clinical significance. For example, sometimes what happens is that you may get a correlation very high, 0.9 or 0.91. It may not be statistically significant. Another possibility is that you may get a very poor correlation, which is 0.1 or 0.2, but statistically significant.
Okay.
But let us have a look. The third possibility is you may get a high correlation like 0.85 or 0.9, which is statistically significant.
Mm-hmm.
Out of these three possibilities, third which is really useful for us because it is clinically significant and statistically significant.
Okay. Okay, so
First example, if your correlation is very high, but if it is not statistically significant, it indicates that the observed correlation is just by random chance.
Okay.
Second example, the correlation is very small, but though it is statistically significant, for a clinician, it is a non-significant correlation.
Mm-hmm.
But for the third example, which I told you, like if it is a more than like 0.87 or 85, and if it's statistically significant, it has some meaning in the clinical practice, like both clinically significant and the statistically significant. This is which I have mentioned.
Okay. Okay, sir. Thank you. Got it.
Dr. Asay Nandeshwar, please ask your query.
Hello. Hello.
Yes, sir. Audible.
Am I audible, sir?
Yes.
Yes.
Thanks for very informative lecture first. I just want to know one thing, sir. How correlation regression it differs from parametric and non-parametric other tests. So, why we cannot put it in those standards, means like t-test and other tests? Hello.
Once again, just ask me. I'm not clear for it. Just.
No, we have got other test of hypothesis also, no? Like parametric and non-parametric tests are there, like t-test, chi-square test, and other tests are there, no? Kruskal-Wallis and others. So why correlation and regression is different
The
from those
answer is
particular?
each test has different purposes are there.
Right.
For example, It is not like a parametric or non-parametric. Even parametric itself, we have tests are there.
Right.
Equivalently, we have non-parametric tests also available.
Right.
But every test is not suitable in all situations. For example, t-test, independent t-test is used to compare the two mean values.
Right.
Equivalently, there's a non-parametric test called a Mann-Whitney U-test.
Mann-Whitney test.
Yeah,
Right.
it is equivalent to the independent t-test.
Right.
Like that, a paired t-test, the purpose is in the paired observation, but the difference between initial value and the final value is it statistically significant or not. Equivalently, we have non-parametric test also available for the paired t-test.
Right.
And chi-square test, the purpose is when there is a two categorical variables, whether there is a statistically significant association existing or not. But
Right.
the condition is they both are categorical variables. For example, smoking is a categorical variable. It is classified as yes or no. Lung cancer is a categorical variable. It is classified as yes or no.
Right.
Whether there is an association between these two variables, that is, for that the chi-square test is useful.
Right.
Whereas in the correlation analysis, what we are looking, when one variable increases, other variable increases or not. Particularly what we are looking here, it is the linear relationship. So the condition is both are continuous variables. The examples which I told you is distance and the number of visits. Distance is also a continuous variable. Number of visits also a continuous variable. And what we are looking here, it is whether they are linearly associated or not.
Okay.
The last query is from Dr. Dharmen Kumar Pandey. Sir, please unmute yourself. Dr. Dharmen Kumar Pandey, sir.
Hello. Sir. Hello.
Yes, sir. Audible, sir.
Yes, sir. Sir, please explain once again what is the actual meaning of dependent and independent variables.
Yeah, dependent and independent variable in correlation analysis, it is immaterial. We
Yes,
conventionally call one variable as xi and another variable as yi. In
Yes, sir.
correlation analysis, it is immaterial. For example, distance increases, the number of visits increases or not. That is what which we are looking in the correlation analysis. It is equivalently saying the number of visits increases, the distance also, number of visits increases, distance decreases or not. Same thing. Well, another example will be more easy to understand. The examination marks and the time, number of hours you are studying. Number of hours you are studying, if it is more, the chance of getting you more marks is there or not. That is what we are looking in the correlation analysis.
Yes,
So
sir.
their dependent or independent is immaterial. We are only looking the two pairs only in the correlation analysis.
Yes, sir.
Whereas in the regression analysis, our primary concern is we have one variable which is called a dependent variable, and how the independent variable influences it is actually what we are looking in the regression analysis.
Yes, sir.
In the first example which I told you, the distance and the number of visits, we are not worried about the number of visits with the distance, but what we are worried as a medical officer, what we are concerned, if a person is staying 5 kilometers away from the center, but
Yes, sir.
suppose if a patient come and register in the antenatal care, if the patient is staying 5 kilometers away from the center, the doctor should have some initial idea itself, how many visits he is likely to make the whole 1 year, whole 9 months of the period.
Yes,
So in
sir.
that situation, the number of visits is the dependent variable and the distance is the independent variable. So the regression analysis, one is dependent variable and how the independent variable influences the dependent variable. And the second example which we told, the number of marks of the student and the number of hours which we are studying. Our primary concern is the marks is our primary concern. The more hours if you study it, whether you are likely to get more marks. Suppose if you are spending more than 6 hours, 9 hours in the hours for studying, what is the likely marks which you are going to get at the examination. So in this situation, the number of marks is the dependent variable and the distance is the independent variable. So in the regression analysis, this matters a lot. Whereas in the correlation analysis, it doesn't have any role. We are not worried about what is dependent or what is independent.
Okay, sir. Okay, sir. Thank you, sir.
Thank you so much, sir, for very interactive query session. I hope that all participants get answer to their queries. If there is still remaining their queries, then please write to us. You have already our mail ID. You can simply write your queries to our mail. That will be answered after the session. Now, we all know today's chairperson of the session, our respected Dr. Padam Singh, sir. He already delivered many sessions and chaired sessions regularly with us. And the program is near to end. Now I would like to introduce sir. Sir has held many important positions in Government of India. He has been a member of National Statistical Commission, Government of India during 2006 to 9 and has served as Additional Director General ICMR during 1997 to 2004 and Director National Institute of Medical Statistics during 1987 to 97. Sir has worked as Joint Advisor in Planning Commission during 1979 to 87 and Professor of Statistics at Usha Institute. Sir has also been awarded the Sankhya Bhushan Award and is a Fellow of the Society of Medical Statistics, which is higher honor for a statistician. Dr. Padam Singh sir recently awarded Pandit Ramakrishna Pandey Lifetime Achievement Award from the Institute of Applied Statistics in 2022 and awarded with Dr. P.V. Sukhatme Lifetime Achievement Award with 5 lakh cash prize from the Ministry of Statistics and Program Implementation, Government of India. Now, without taking too much time, I would like to invite our respected chairperson, sir, Dr. Padam Singh, sir. Please share some views regarding today's session and kindly conclude today's session, sir. Please, sir. Welcome, sir.
Okay, Amit. Dr. Anil Mathew, yours was a very, very simple presentation, non-mathematical, and in a very simple language, you have tried to explain the concept behind correlation and regression. And you have also explained, dependent and independent, that comes only in regression, not there when we talk of correlation. And I wish if you have touched something on logistic regression as well, when we are dealing with, because simple regression is for continuous variables, for dichotomous variables, and most of the medical researchers, they will be interested knowing more on that. Maybe there could be another session or another lecture on logistic regression. I don't know that part. But Anil Mathew, it was a pleasure listening to you. And I am seeing you after a big gap. And we have shared forums several times. And I think the participants also raised very good questions. Let me tell you, very good. All the 3 questions were very good, very relevant. And we are now already asking them to put their questions and the replies will be sent from the organizers. So I think with this, let us conclude this session and thank the speaker for making this session very simple and interactive. Thank you.
Thank you.
Thank you very much, sir, for your kind words and your valuable time during the session. Now, on the behalf of Institute of Applied Statistics and National Institute of Ayurveda, we convey our sincere thanks to all the participants for their active participation and commitment for today's session. We heartily thank the guest speaker of the session, our respected Dr. Anil C. Mathew, sir, who kept participants engaged by the very informative lecture and very interactive query session. We also thanks Dr. Padam Singh sir for chairing today's session and sharing his experience and views about the session with the participants. Now, this is the end of today's session. Tomorrow, we have one more session that will be delivered by Dr. Anil Mathew sir. Use of linear and logistic regression. So the time of the session will be from
tomorrow. That's fine.
Yes, sir. Yes, sir. So this is the end of today's session. We again join 6 p.m. tomorrow. Thank you so much again. Thank you, our respected chairperson and guest speaker of the session. Thank you very much, sir.